Assalamualaikum. I'm from group 45. I'm Siti Mariam Meti Muhammad Noor, and my members group is Azim, Mukri, Noshazlin and Azila. I want to share about test shear force and bending moment. For introduction, the shear force at any point along the beam is the total force acting perpendicular to beam longitudinal axis up to the point. For the bending moment at any point along the beam is equal to the area under the shear force diagram up to the point. For a simply supported beam, its bending moment at the ends will always be equal to 0. For the objective to determine the shear force and bending moment at the particular section and compare with the theoretical calculation.
Hi everyone, I'm Nur Azila. First experiment is about shear force. At here we need to conduct shear force variation at cut section XX due to variation of load and load position. Here is a sample for the apparatus. We have a beam. Here is a point A, point B, point C at the end, and point D here. And this is a value for reaction at B. We call it RB. And this is reaction at C. We call it RC. This is the cut section XX, where the shear force will be measured. We go for case 1. The load 100 gram is placed between point A and point B. The value of shear force at section cut XX is measured. This step we repeat. We increase the load to 100 gram and 300 gram. For in case number 2, the step is repeat by moving the load at any point in between point B and point D. I put here in between B and D. And then for the next case number 3, the step will repeat and placing load at between point D and point C on here. Okay. This is the load I put in between point C and D. And the value of shear force at section XX here will be measured. After that, we need to plot a graph related measure shear force with position of load P apply. Thank you.
Assalamualaikum. Today I will show you the experiment of superposition for shear force. Here I have one long span. The length of the span is 580 mm, and this is point, this is pin, and this is roller. This is point A, point B, point D, and point C. The distance between A and B is 140. B to D is 300, and D to C is 140. And for the first case, I will put the point load here. The distance between the sunpot and the point load is 60 mm, and the weight of the point load is 200 gram, or same as 0.98 Newton. And then we will calculate the reaction at B and at C. And then here also I have X section, and after we calculate direction here and there, we can get the moment at D. Okay, for the second case is the distance is 120, and I put it here, and we will calculate same as the first case, just we change the distance here. Okay, for the third case is 180, I put here, and the last one is UDL. I'll put 3 here, 1, 2, and 3. The distance between the support and the UDL is 60 mm. This is the distance between point to point is 60 mm and 60 mm. The total is 120 mm. And the total load for this UDL is 5.88. Thank you.
For next bending moment experiment, set the apparatus like this. This is point A, point B, point C, and point D. Cut section at point D. First step is put three some load between B and D. Distance load is same, 60, 120, and 180. Then we measure the distance and we will get the bending moment. After that, repeat the same step at point A and B, which adding point A and D, which adding the load P4. The repeat we change between A and B. Lastly, we need compare the theory value which our value bending moment. First, we need to measure and calculate the bending moment at section XX. When load applied at point 1, distance will follow the question. Next, the step is by changing the position of load to point P2, P3, and P4. Then we need to measure and calculate the bending moment at section XX. Lastly, use the formula of superposition to discuss and calculate the bending moment. This is the formula.
Demonstrate about contraflexion. So basically we have our frame, and one more thing is we set up our frame, our beam, point A, point B, point C, and the cross section. So first thing, when we need to cut the cross section, we need to make sure the cross section between point B to the cross section measure as 400 mm. Okay, after the measurement has been made, we put the P value between the cross section to the last point C. After that, we measure P, the distance between point B to the value of P. And then this experiment will be repeated when we add on our P value. Hi, my name is Mukri. I would like to demonstrate how to find the maximum hogging or maybe maximum sagging. So basically, we have our frame. As you can see on your in front of you, we can let this as a point A, point B is our pin, point C is our roller, and the cross section XX. So first of all, we apply on the load at point A. This is basically according to data, we get 200 gram, and then we apply the load point D to point C between. This is the P, our P, this is our W, and then we read the reading. So we plot the shear force diagram. After then, we plot the bending moment diagram. So as a result, when we apply the load on point A, between point A to point B, the maximum value is negative. This is called hogging. While when we apply load between point D to point C, or maybe point B to point D, we can get the value maximum is positive. That's we call sagging.
Hi, my name is Azim from Group 45, and today we are going to look at the bending moment data for variation of load and variation of position. So let me brief you all about this setup. This is our beam, and this is our support, this is our pin support, this is our roller support. And here we got point A. At the support we have point B. At the roller support we have point C, and here we got the cross section point D. Let's take a look at case 1. Case 1 is where it is a variation of load, and we can observe the bending moment data from variation of load. So for case 1, we will put our load at point A. Each of the load is 100 gram, and the distance is 100 mm, 100 millimeters from the support. Next, we are going to add more weight, more load onto the same position, and we will observe the bending moment data. We add another 100 grams, and the third one we will add another 100 gram, which totals up to 300 grams. So let's see case 2. Case 2 is where it is a variation of load position compared to the first one, which is the variation of load. So in case 2, the load will be the same, but the position of the load will differ. So the first one, we will put the load onto the first position, which is 100 mm from the support, and the next one we will put the load 140 mm over here, and the third one we will put the load 380 mm from our pin support. Thus, we will observe the bending moment data created by this case, and also the first case, which is the variation of load. Thank you.